Thanks. Okay, so good evening, everyone.
Good evening, sir.
Good evening. Okay, so let me introduce myself. My name is Srikanth Venkateshan. So I'm the course instructor for today's session. So today's session we are going to deal with week 1 activity and practice. Both. Okay.
Okay, sir.
Okay, let me share my screen first. And yeah, and congratulations to everyone for passing term 1 and moving to term 2. How are you guys feeling? Anyone would like to share something?
Like this term is completely different. Like the pace is different and difficulty is different. Like now I'm feeling that term 1 was a lot easier. Then
Right, this happens everywhere, right?
yeah.
Sir, you told not to meet again in Max 1. So yeah, we're
Yes,
meeting
sir.
Oh,
Max 2.
there are
Last session you told let's meet in.
yeah.
Yes, sir, we're meeting here.
Yeah, good to see. Okay, okay then. Let's start. Is my screen visible?
Yes, sir.
Yes, right. Okay. Okay. This is about stats 2, week 1. Okay, how shall we do this today? Shall I explain the topic and do some activity questions, or you guys are having questions with you?
So you can explain first, I think.
Yeah, you can explain first and then we'll ask
Yes,
questions.
sir, you can explain.
Okay. We will proceed like that. So in stats 1, we have seen we started from mean, where what is mean, what is okay. We started from what are different types of scales, and later we pushed to what is small data. We computing mean, median, mode, and everything, and later we looked into some probability. We got into probability, and later you might have studied some distributions. And let me ask this: how many of you have gone through this week 0 content?
Sir, skimmed through most of those because it was like a revision session.
Yeah.
But
It's just basic revision of stats 1. So you might have taken some 15 days break, right? 15 or 18 days break. So in order to just refresh yourself, it is like a refreshing week.
Sir, can you
I
tell
did the
which
activity for that.
Yeah.
It,
So like
so it is very good actually.
Yeah.
some of the new concepts were there.
One by one, please.
sir, can you name the new concepts that are there in week 0?
No, nothing new. See, some distributions like Poisson distribution.
So, sir, we have to study those distributions ourselves.
No. Even that will come in week 1. Week 1 में, week 2, week 3 में. फिर से we will look into the distributions first, and later we will discuss the concepts. So it's like just refreshing. It's not that important, but it's like अगर time मिला, just go through the week 0. Okay. It's not like if you didn't see week 0, you can't. It's not like you can't read week 1 or week 2. It is just a refreshing week. So just we refresh what all the contents we discussed in stat 1, along with some small distributions that will be again retaught in the lectures.
Okay.
Okay. So then, yeah. Okay. Let me ask few questions from which requires. What is a sample space?
The
Possible outcomes, list of all.
possible outcomes.
Okay. Very good. So what is event?
event
A
space.
subset of the sample space.
Some
Subset of
outcomes.
sample space.
Yeah.
Right. Subset of a sample space. Yeah. Collection of possible outcomes. Some collection of that bigger sample set. Now, moderate question. What is random variable?
It is a variable which outcomes are depend on a random phenomena.
Function defined on the sample space.
Defined on sample space.
Sample space to
and
the real line.
codomain.
A function that outputs something from the sample space itself, but based on probabilities. That's why it's called random variable.
I think function defined from a sample space to a real line.
No, it is
May I
defined
know
to
your
the
name?
sample space, right? It will give the sample space like based on the probabilities.
Yeah, the output is from the sample space dependent on probabilities.
Right. Simply, this sample to the set of real numbers. Okay, so it is a small function. It's like a treat it like a function where our domain is like the sample space, and the codomain is the set of all real numbers. So even here. Okay. Okay. So when I say a random variable x is actually a function where it maps from S to real numbers R. So this S is basically the sample space. So which is the set of all possible outcomes. Right now we know that this is the random variable. So let's play with this random variable. So in week one, we generally start from looking at the probability mass functions. Okay, what is probability mass function? This is a new thing, right? New thing, or have you guys have gone through the PMFs, right?
Yeah, it is there in the chat.
Yes, sir. Yes, sir.
What is this probability?
Mass function.
Yeah, mass function. No one. No?
It is a function which can give the probability for each value to the random variable.
Little louder.
Am I audible now?
Lee.
Yes, sir. Am I audible now?
Yeah, but it would be good if you speak a little louder or increase your mic volume.
Okay. Like is this better now? Like
Yeah. This is okay.
So I think it is like EMF is like a function which gives it gives the probability for each value of the random variable. So,
Right.
May I?
Yeah.
Sir, according to me, probability mass function is a function that relates the various outcomes of any random variable with the probability of it happening.
Exactly. Correct. So we have seen a random variable, which is a function. Now, even this probability mass function is also a function where we denote it like fx. If I say only one random variable is there. So fx is a function from, so this is, if this is x, this is a random variable x. So look at here, this is a random variable x. Now, this random variable x outcomes are real numbers, right? So this x can take, if I say x range of x is is a subset of R, right? Now, yeah, discrete random variable. So we are, as of now, we are talking only discrete case. Okay, we are not going into continuous case. We will go into continuous case in future maybe. Okay. So as of now, treat it. We are talking only on discrete. Okay. Now x is a function. Range of x is will be the, if this is the codomain, that will be the range of x will be the subset of this real number R. Now this subset, which is range of x, I treat it as tx. This is just the denotion. So if I say tx, so this tx will map to something in between 0 to 1, 0 to 1 line, because each and every probability, one of the property of probability, right? Probability will always lie in between 0 to 1. So probability of happening, if the probability of happening such an event is 0, that means that event will never happen. If I say probability of event happening, it definitely happens, is like probability becoming 1. So whatever the probability is basically a chance of happening of any event, of any experiment. So chance of India winning test series against New Zealand, or like this. What is a chance? Chance is basically given with respect to 100%. So there is a 60% chance of winning or 50% chance of winning. So when I wanted to talk it in points, so chance is basically spoken percentages. So when the same thing, we call it as probability by dividing it by 100. So 60 by 100 is somewhere around 0.6. So probability of India winning test series against New Zealand is 0.6. So that is what probability is. So probability will always lie in between 0 to 1. So our range of x, each and every, so this range of x contains some set of numbers. So each number will map to the probability of that particular number happening. So that is basically the PMF. So there are, this is simply, I can write it as fx. If I say this is a function of some particular event, I say t1. So t1 is an event here. So which is subset of this.
Tx represents all the events together, right?
Right. So tx actually represents all the set of possible outcomes where it maps to the real number. So yeah, tx is basically all the set of all outcomes, but in real, what I say, it's not set of all outcomes, but set of each and every outcome is now denoted as some number.
Sir, it's elements, all the elements present in the range of random variable x, right? Yeah.
All the?
It's a range of
all the elements in the range of random variable x, values taken by random variable.
All random variable x. So what shall I say? Simple examples. See, if in statistics, in this courses, if you take an example, it is very easy to understand. Like, so a standard well-known example is head and tail. Tossing a coin, head and tail. So samples place will be either it will be head or either it will. This will be the sample set. Right now, this random variable x, how I define is x is equals to 0 if it is a head, x is equals to 1 if it is tail. I just wanted to count how many number of tails are occur. So this is this particular random variable. Actually, now the range of x is 0, 1. So x is basically h to t to r. So my x takes 0 when an head appears. X takes 1 when tail appears. Now my x can take only 2 values, right? Either x is equals to 0 or x is equals to 1. So my range of x will be either 0 or 1. So my range of x means tx will be either 0 or 1. So this particular tx, now 0 maps to some number.
Defining the tx, is it necessary? Because we can simply work with saying probability of x equal to h and x equal to t as well.
Every time, see, writing those things, to simplify this, we write it like this. It's like, see, now if you wanted to write p of x is equals to chance of happening head appears. Every time an experiment will not be in numeric, right? So tossing a coin, appearing head is your event now. So in order to represent that particular event, we will map that particular event to some real number where we simply use that x is equals to 0 here. So now see, this is the thing happen. See, now probability of x is equals to tossing a coin, head appears, okay, head appears when we toss a coin. So this is the event. This is one event, right? This head appears when we toss a coin, and another event is it appears tail appears when we toss a coin. So every time writing these things, what we say, it's to in order to reduce our work, or
So yes,
in order to standardize the thing.
it's for like a convenience, but it's not necessary, right? That's the entire idea.
Also the standardizing. See, every time here only two things. Okay. What if your experiment contains some 2 power n outcomes, and each of the outcome you can't even write it in words?
Yes. Case of Huntington, right? But in case of other things, you can write. All events cannot be written.
Yeah, all events. Writing all the events in words will be difficult to write. So if you
how to standardize intuitively?
How
to standardize the statements given in the problem intuitively, so that it can be converted to.
That will be that depends on us, right? So if you say a coin is tossed 10 times, and I want to find how many heads are appearing. Okay. Now in this case, what I will do is x. I will define the function x, the random variable x, such that x is equals to 1 when head appears, x is equals to 0 when tail appears.
When head does not appear. When head does not appear, we can say.
When head does not appear, right?
Right now, because we will do only for the heads only. Then head appears, then it is 1. When head does not appear, then it is 0.
Yeah, head does not appear. Yeah, it is same as tail appears, but yeah, head does not appear is
here it is, but in other
right. A coin, yeah. Now see, if you are not taking into this random variables, so if I ask you what is the probability that head appears 6 of the times, exactly 6 times, like this, or head appears at least 2 times. So that means it is easier to look in the numbers way. If we have numbers, it is easy. It is actually asking, if I say at least 2, so head appears at least 2, that means I have to find probability of x is greater than or equal to 2. It is sufficient to do this if I take the random variable x. If I am not taking random variable x, and if I am only considering the events, that may take you long time to compute calculations also.
Yes, sir. Understood.
Yeah.
Yes,
See,
I
these are
understood
very
that.
smaller examples. Okay, these are tossing coin 10 times, 5 times.
Yes.
So now that we have progressed 2021 years ahead, and science actually started from BCs. Okay, so we have a large data with us. So these are pretty small data compared to that data we have now. This is very small data. If you want to play with that data, obviously converting the data into mathematical or statistical world, it will be easier to compute or easier to predict future calculations, or whatever we can play around if we convert everything into our mathematical world. Okay. So yeah, let's come back. So we have seen probability mass function of one random variable maybe. Now, what we do in statistics too in this course is we actually walk through two random variable cases. Okay, two random variables are like a random variable x, and also there is another random variable y. Now we look at what we look into is we know individually what is the PMF of x and what is the PMF of y, how this x is distributed, how this y is distributed, and where this x and y are defined on defined in some probability space, right? We define this x and y. So what is the range of this x and what is the range of this y? But when we combine these two, so when I say both the random variables, if this random variable is taking some value, and at the same time that y random variable also taking some other value. So whether these are, if this x and y, these random variables are dependent to each other. That means if I say small example is like, yeah, if I say in the lecture also sir has taken this example, I guess. So in an IPL over, if you are if all the 6 balls are hit to 6 sixes, so there if I say x is the runs scored in an over and y is wickets taken. So y independently can have 0, 1, 2, 3 and so on 6, right? Maximum in an over we can have so 6 wickets, maybe 6 wickets have fallen. And even the run scored is can be from 0 to 36, or maybe excluding no balls and everything, let's consider 36. So x range will be from 0 to 36 and y range will be from 0 to 6. So now is it good to say that x can take value 31 and also y can take value 4? So that means in a particular over a batsman is scoring some 30 runs and also 4 wickets have fallen.
No.
Not
Is this
possible. Not
practically
possible.
Not possible.
Not possible.
No, right? So that means this particular x is actually dependent on this particular random variable y. So this trend we can actually look into, like if x is more, like it is actually going to some above 20 or above 25, then y takes very less values like 0, 1. So not more than 1 or not even 1. So if a batsman is on a form, it's a very less chance or less probability that he gets out in the tour. Right? So that means what if some random variable is depending on the other random variable, and if we wanted to find the joint probabilities of this random variables x and y, there comes this. So finding this PMF, what actually gives us is each event ka probability how much. So we can compute each and every event probability is how much. So now what we do is we try to find the joint PMF which is jointly distributed. So how will we have seen the we know the distribution of x independently, we know the distribution of y independently. What we see here is we see the distribution of xy. So both the events, what happens when I consider both the random variables together, and if I wanted to look into what happens when x is 0 and y is 0. So what is the PMF of that? So what happens when x is 1 and y is 3? X is 10 and y is 6. So I wanted to look at jointly. So that means and. So what happens when this x taking value some a and also y taking some value b? So that is what I wanted to see. So in order to see that, what we do is we try to find this joint PMF. Once we get the joint PMF, from there it is very easy to get the probabilities of each and every particular event. So what is this joint PMF is? This is, yeah, as we have seen, PMF of some random variable x is some fx. So this is just the denotion of that joint PMF. So where we denote it as fxy. So this is a function. It goes from tx cross ty. So this is something two-dimensional. So tx is and single dimensional. Tx cross ty is it will be in pairs, ordered pairs. So 0, 0 or 0, 1, where this 0 comes from this tx and 1 comes from this ty. Likewise. So it's like an ordered pairs. So elements in this are ordered pairs. So this set is basically range of x cross range of y. Right? If my x is 0, 1, 2, if my y is 1, 4, so my tx cross ty is, so it's like a sets. So these are two sets. So this is tx ty. So here also this is tx and ty. These are range. So this is tx and this is ty. These are two sets here. This is tx cross ty. So a cross b, two sets ka multiplication or two sets ka product. So it will be like 0, 1, 1, 1, 2, 1, 0, 4, 1, 4, and 2, 4. Right? So if you have two sets, the cardinality of tx is 3 and cardinality of ty is 2. So what will be the cardinality of tx cross ty, or how many elements will be in tx cross ty?
6.
So it's like 6 and 0, 1, where 0 comes from this tx and 1 comes from this ty. Likewise. So that is how this tx cross ty elements looks like. So this tx cross ty, now it will map to 0, 1. It's the same probabilities. It takes probabilities. So what we have done, what is the difference between the initial PMF and this joint PMF is, we are looking the PMF of jointly combined x and y. So where the range will be tx cross ty instead of tx, single random variable. Here we will look into tx cross ty, ordered pair ka outcomes. So even the outcomes will be like tx cross ty. So if both the events should happen, so first one will be first event and second one will be the second event. So both are happening, comes as an ordered pair. So this fxy is the joint PMF. So what is this fxy is? So this 0, if I wanted to generalize, I say some t1 and t2. So let's use professor's terminology only, notations only. So this t1 is basically one event of this tx. So basically this t1 comes from this tx and t2 comes from this ty. So fxy of t1 comma t2, two elements, right? T1 comes from tx and ty. This will be equal to simply the probability of x is equal to t1 and x is equal to t2. Okay, so it's simply, again, this is small notation. We, in order to remove this and, we just keep comma. So we have this fxy of t1 comma t2 is basically the probability of x is equal to t1. That means x is taking the value t1 and also x is equal to t2. So this is what fxy t1 comma t2.
Sir,
X is equals to t2. T2 comes from the y, right? So it should be y is
Yeah,
equals to t2.
yeah, right. Sorry. Yeah.
Sir, how are we going to represent this like geometrically? Like when there is one random variable, we can graph it and we can like find the properties of that graph. So can we do that here?
Doing that here, it's like a 3D, three-dimensional graph you should look at. Okay. So in 3D, what happens is x and y, you take xy. In z, you just represent, you just draw a straight line above, depending upon the probability. It forms an region like thing. So area under the region will be 1. So like this. So this will be like a 3-dimensional. So x, y, and this one is z. Okay, straight. So now what we do is, if x is 0, y is 0, we draw a straight. Okay, let me take a small example. So okay, let us take. We roll a die 2 times. Okay. Now what I wanted to look at is x. I define 2 random variables here. X as number on dice 1, number on dice 2. Okay. So now we know that how to compute the probabilities of each and every. Okay, let us start from the base. So what will be the range of this Tx? So that means what can x take? Actually, x is number on dice 1. So what all the possible values of x can take?
1 to 6.
1 to 6.
4, 5, 6, and that will be the range. So same goes to Ty, right? The same thing. So even it is actually the dice 2. So it takes 1 to 6. So now actually we can compute these things, right? Probability of x is equals to 1 and y is equals to 1. That means if you see here, x and y are independent. So from there you can actually write it, p of x is equals to 1 into p of y is equals to 1. But also I don't want to do it in that way. So you see, this is again a combined event where it tells us that my first dice shows 1 and my second dice also shows 1. So now you know that if a 2 dice are 2 times a die is rolled, okay, 2 dice are thrown, not 2 times.
2 dice at a time or 1 by 1?
Huh?
Dice are thrown 1 by 1 or at a time, simultaneously?
At a time, 2 dice thrown at a time.
Simultaneously.
Yeah. This is number
So
on die
Z
1.
would have 1 by 36 as the height of 1 comma 1 point, and
right.
So like whatever the curve or like
Yeah,
plane
wherever the
will be
point
there.
comes.
So what would be the properties of that plane? Like I am not able to
Okay.
visualize it.
So see,
It is uniform, so probably it will be like a straight plane, like a plane parallel to that XY plane.
no, it is not.
36.
It is not uniformly distributed. No, it won't be uniformly distributed. I will show you. I will use different colors and you may get some. Okay.
So sorry to interrupt. Just one conceptual thing. Maybe it is obvious, but I'm not sure. 2 dice are rolled, but what is the difference if 1 dice are rolled twice and then we take the observation? How will it make the difference? If we are rolling 1 dice twice and the first time we make it for X and the second time we roll it for Y. So then also the case should not change, right? I mean, what is the emphasis on 2 dice are rolled?
No. See, I just mentioned here die 1 and die 2. That is why I just changed it.
Yeah, but it will not differ, right, in the calculation.
No.
Right?
Unless and until the experiment is completely different and there is a dependency on the first die.
Yeah, if the
No,
dice
there
are
is no
biased, then there
dependency.
might be a
No, I'm not saying of any unbiased dice. It's a normal fair die.
Yeah.
If we roll 1 dice 2 times also, it would be the same thing as 2 dice are rolled, right?
Right. But
Yeah,
it's
okay,
it's
fine.
it's a different experiment. That's it. So the name of that experiment is we have 2 dice in that experiment, but here we have only 1 die. That's it. All the probabilities or all the properties what that particular experiment holds, the same thing holds here also. Okay. Yeah.
Sir, that
So
like previously what I have said that it wouldn't be a plane because this is discrete, right? So it wouldn't be a plane. Like there will be discrete like what else say like candle type stuff here.
So this point 1 comma 1 is possible, right? Like
Yeah.
die 1 showing 1 and die 2 also showing 1. Is this possible?
Yes.
Yes,
This
yes,
point
yes.
1 showing 1 possible. With probability, like chance
1 by
of happening
36.
1 by 36.
right 1 by 6 into 1 by 6, which is 1 by 36. Now
Yes.
you just draw a straight line of length 1 by 36 like this, but perpendicular to this plane xy. Okay, at this particular point 1 comma 1. Okay. Now likewise the same thing, we have 36 different outcomes, right?
Yes, sir.
So
For 1
die
comma
1
2.
has 6 outcomes and die 2 has 6 outcomes. So there are 36 different outcomes possible. Out of those 36 outcomes, some are maybe equal, like dice 1 getting 2 and dice 3 getting 3 is equal to dice 3 die 1 showing 3 and die 2 showing 2, like this. So if you calculate one thing ka probability, okay, here okay, sorry,
But it will be represented differently in the graph.
yeah, the same thing. So whatever the number shows, so what is the probability of x is equal to some number taken in between 1 to 6, which I say something a, and y b. So what will be this probability?
1 by
1 by
36.
36.
Again 1 by 36.
Right. So that means at each and every point, like this 1 comma 2 or 1 comma 3 or 1 comma 4, 1 comma,
Yes.
like this, all the
Everyone
36 points
will have that same height.
will have this height like this. Okay. Oh, I said I will use different color, but I will. So there will be 36 spikes which are perpendicular to xy plane and also equidistant to each other. Okay, if I see xy plane here, let us
So
say
perpendicular
this
to
is 0.
xy plane makes it 3-dimensional plane. So
Yeah, it will make a 3-dimensional plane. So or let's say paper same. Okay, like this there will be 36 spikes at points 1 comma 1, 1 comma 2, 1 comma 3 and so on 1 comma 6. Likewise 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 6, 3 comma 1, 3 comma 2, 3 comma 6. Likewise 6 comma 1, 6 comma 2, 6 comma 3 and so on 6 comma 6.
So how can we say that this 1 by 36 is a link to the line perpendicular to the plane itself? Is it
How can
geometrically
you say?
correct?
How can we say?
How can we say 1 by 36 is the length of the line above the xy plane and along the z? Is it geometrically correct, or we are just making an imagination it will be the length of the line?
No. Z represents probability. So we are using 1 by
Probability.
36.
Z actually represents the probability. So this is the probability. Okay, z-axis represents the probability, and x-axis represents the all the value set of values taken by random variable x, and y represents the set of values taken by Random
So
variable,
even if there are more than two random variables, z-axis will represent probability, right?
No. Even if it is 3 random variables,
Yeah.
then it is very hard to imagine the axis, because fourth dimension cannot be brought into 2D plane.
But we have probabilities for more than 3 random variables, right? If they are conditional
More
on
than
each
3
other.
random variables, yeah, you have, but it's all about intuitively you have to look into. That's it.
Can we
Intuitively
apply
you have
the
to feel it.
center of mass analogy here?
Huh?
Like in one random variable, the PMF that we get, we can like put an analogy of a center of mass. Can we do here?
Analogy.
Voice is not.
I don't think so. Let me again reread this and get back to you. Okay, I'll just look whether we can actually bring up something with these 2 random variables. Okay,
Excuse me,
Adit.
sir.
Hello.
So the two scenarios which have just been mentioned by someone, rolling a die twice and rolling a die twice one by one and rolling 2 dice simultaneously, will both the things will have the same, such as the sample space and probabilities of every events in this case would be same or not?
I think it will be same because both are independent.
Yeah, it should be same.
Yeah.
It will be
Yes,
same, but the
yeah,
thing
it
is,
will be same.
it will be same. But the thing is, we cannot imagine just for the representation. Here we have used 2 dice, but if you like second dice, whatever you're telling, that how you'll represent the second Y set. If you define that all the even outcomes will be from the second dice, so you cannot bound that, right?
Yeah.
So it will be complicated, like representation
Yeah,
and
if we are
making the
taking the
people
same
understand
thing,
will be difficult.
yeah, it would be
Suppose
difficult to interpret
suppose I
this.
have given you one sample, suppose 4 5. How you'll define on which times first 4 came on the first dice and on which times 6 came on the second dice? So but the thing is, event is independent. If you define it clearly that
It is
first
better.
dice will be this and second dice.
So the events become independent when there's a conditioning happening.
Yes, event will be independent. Event will be independent.
Fine. I just want to know that both the things would be same, na, inside it, like events, all the things, the sample space and every probability.
Yes.
that would be-
Sample
yeah.
space,
Sample
everything
space will be
same.
same.
The only thing is you will it will be difficult to define those things. That's why for
But in this
simplicity,
case, no.
yes.
Yeah. Okay.
Yeah.
For the nomenclature purpose, we are doing like that.
Hello.
Yes.
Am I audible? Hello.
Yes, sir.
Yes, sir.
Yes, sir. You are audible.
Yeah. Okay.
Please.
My system is getting stuck in between. Sorry for. Okay. So you are just asking someone some Shruti or some.
So my issue has been
Christine.
resolved.
Okay.
Thank you, sir.
So yeah. Okay. So what we do now? Shall we take some examples? So this is what PMF is. Okay. So that is joint PMF is.
But I was
So joint
asking that
PMF is.
if we can connect this to center of mass analogy.
Yeah.
like
I
we
will.
did
I will.
for
I will
one
take a
variable.
look at it and I will get back to you.
Yes.
Aditi.
Thank
Okay. Yeah. Okay. So this is how we define this joint PMF, where this fxy. So x taking random, x taking some value t1, y taking some value t2 is same as probability of x taking t1 and y taking t2 at the same time. So how we show this PMF is basically like a table or matrix. So x is taking values here and y is taking values here. So whatever the values of x takes here, we write it here. Whatever the y value takes here, we write it here. And this particular entry, So let me take 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. So this particular entry denotes that probability that this is probability that x is equal to 0 and y is equal to 0. Okay, so this comes here. Likewise, here the second entry in the first row, the second column. So now that you are studying, I hope you have taken Max 2 course also. You know what is a matrix is. And this particular entry is probability of x is equals to 1 and y is equals to 0. So this is how the table goes. We fill the table depending upon the, here the number of columns will be the cardinality of the range of x, and the number of rows will be the cardinality of y, random variable, range of y, right? And
Yes.
yeah, some properties are like, as these are probabilities, so each and every entry should be in between 0 to 1, and once you add up all the entries you should get 1. So if I say, I will just take a small example.
Yeah.
So this is x
Please.
and this is y.
Tabulate.
X is taking 0 and 1. Y is also taking 0 and 1. And I define x as number of heads. And y as number of tails. The thing is, our experiment is we have just tossed the coin only one time. Toss a coin only one time. So this is the experiment. So we just toss the coin. Huh? What will be the range of x?
0, 1.
0, 1.
0, 1, right? Like, see, if the number of heads, if the coin tossed, if it is not head, then x will be 0. If it is head, x will be 1. Similarly, similar case goes to here. Now tell me, this particular entry actually tells us that probability of x becoming 0 and y becoming 0 at the same time. So what will be the probability that
0.
when I toss a coin,
0.
it is not head and also not tail?
0.
0.
0. Now let's come to this one. X is equals to 1 and y is equals to 0. Actually what it tells is, when I toss a coin, I will get a head, and at the same time I won't get tail. So what is the probability of getting head and not getting tail?
Half.
1 by 2.
1 by 2.
Yeah, right. So this will be 1 by 2. So the same thing here also. X is equals to 0 and y is equals to 1. That means not getting head and getting tail. What is the probability of not getting head and at the same time getting tail? So if we are not getting tail, that means actually it is getting tail, right? Not getting head means actually we are getting tail. So what will be the probability here? What will be the probability that
1 by 2.
Here it will be half. And
0.
Probability of getting head and tail at the same time? 0.
Yes, sir.
So this will be the joint PMF of x and y. This particular experiments, this particular random variables x and y, this will be the joint PMF, which is a matrix of 2 cross 2, because range of x is, the cardinality of range of x is 2 and the cardinality of range of y is 2. So the matrix will be, or the table will be of 2 cross 2. So similarly, if my range of x is something from 0 to n minus 1, okay, and ty range is from 0 to m minus 1. So tell me, how will my joint PMF table, how many rows or how many columns will my joint PMF contain?
You will have 0 to n minus 1, right? And
n into m rows.
M into N.
So n columns and m rows.
yeah, n
Right.
columns.
Let's say these are columns. These are columns, and these are rows. So now tell me, how many columns and how many rows will be in my this joint PMF table?
M cross N.
N columns, m rows.
N columns, m rows, right? So my x takes 0, 1, 2, 3, and so on, n minus 1, and my y takes 0, 1, 2, and so on, n minus 1. So 0, 1 to n minus 1 will be n columns, and 0, 1 to m minus 1 will be m rows. And in matrix denotions, it is m cross n. Okay, rows cross columns.
So may I ask a
So
question?
don't worry if you don't know this also. Huh?
May I ask a question, sir?
Yeah, sure.
So will it be valid to have this question? For example, two dice are rolled, right? The range of one dice, can we consider it, let's say 1 to 3, and for the other dice we can consider 1 to 6. In that particular PMF, the probability will not reach to 1 by the probability, the sum will not be 1. So is this question correct or wrong?
Sum will not be 1. Why? It should be 1.
Because we are considering just 3, 1, 2, and 3 out of, when we are rolling the dice first time, we are not considering 4, 5, 6. We are just considering 1, 2, and 3.
Oh, but there is a chance of happening 4, 5, and 6 also.
Yes.
Chance of showing 4, 5, and 6. Then that is not a complete joint PMF, right?
That's what I'm trying to understand. How would we,
Three-sided
what would
die?
be the interpreted? Sorry?
Three-sided die you are mean?
Not
So you
three-sided
are
die.
just you are
Normal
just
die, we are
crossing,
rolling
or
it.
you are just okay. You are just writing half of the table, right? Not the complete table.
That is not possible.
Yeah. So
That is not
what it
possible,
seems
right?
is
Yeah,
not
that is not possible.
possible, or we don't even talk about subsets of some joint PMF tables.
Okay, fine, sir.
There is
Got
no
it.
no
One
word
thing,
called
one
subset
thing
of
we can imagine, sir. One thing we can imagine. We throw one dice and one toss at a time. Then one dice and one toss. Coin and one dice.
Okay.
Thrown
Yeah.
at a
See, the
time.
thing is,
Both
the
one,
thing is,
one.
he's not
It can
telling
happen.
us
Na,
two
sir?
events. Yeah, it can happen. He's not telling us two events. He is just asking me, asking us that if there is a case that I am breaking my PMF into only considering only half of the cases.
That is
all
not
the
possible.
cases.
That is not possible.
Yeah, that is
not possible.
So,
Yeah, but
those cases we won't
this is
even
possible, no, sir?
Yeah, these are possible. These are all
coin.
events and experiments you are telling us, and we can combine one
Independent
experiment to other
experiments can be taken back.
Yeah, independent or even dependent. We will see what dependent, how dependent PMFs looks like.
Can you give one example of dependent experiments, sir, on the joint?
So that
Of course,
run
I will
and
give.
over example that you give first time, wasn't that an example?
Yeah, that is a dependent. That is a dependent.
Or dependent experiments. Or dependent experiments.
Dependent experiments.
Yeah, two dependent experiments. We are considering here only independent experiments. One is not affecting the other. But
one is not affecting the other.
Can you give some example of dependent? Yeah.
Of
Can
course,
you give
of
the
course.
example of
See, there are
dependent
many
experiment? One is
examples.
dependent on.
Okay. In a 52 cards, if I say if the in a 52 cards deck, in a deck of cards, 52 cards, let's say there are first experiment is I first random variable or X I say, okay, I am drawing out of this 52 cards, I am just drawing 4 cards.
Yes.
Okay. Now X denotes, X random variable X denotes. Okay, this is just the notation of number of
Total
queens.
number.
Okay, number of queens. Okay, after drawing 4 cards, I'm just looking at this actual random variable X gives me the number of queens out of this 4 cards. Okay. Okay, there is 52 cards in a deck. I'm just randomly drawing 4 cards, and after drawing those 4 cards, how I define my random variable X is number of queens that appear on the 4 cards, on those 4 cards. If there are no queens, my random variable X takes 0. If there is one queen among those 4 cards, my random variable X takes 1. Likewise, so my random variable X can take, so the range of Tx will be either 0, 1, 2, 3, 4, because all the 4 queens can be drawn
Right.
among those 4 cards, right?
Right.
Now my Y is number of kings. Okay. Now tell me, is my X is dependent on Y, or whether my X is not dependent on Y?
No, sir. It is not
No,
dependent.
it is not dependent.
It is not dependent.
Like dependent event will be defined like, suppose X is a drawing queens, and Y is a first X random variable X is drawing 4 cards, random 4 cards, and random variable Y is defined as drawing a queen. So queen is drawing a queen depends upon the first 4 card draw. Like,
So it will depend whether it is on replacement or without
If
replacement.
there's if all the 4 cards are queen,
It would be always without replacement.
Always without replacement.
This is
Yeah, because
is
you are
without
picking
replacement.
queens. Yeah.
Yeah.
And then it is dependent.
Yeah,
So
if it
it
is
will
less
be
than
dependent in such
it
case.
is
dependent.
It is dependent now
Because out of 52 cards, you are removing one queen, it becomes 51 cards. So
yes,
drawing 4 cards at a
So
time.
if Y is the case, we want queen of spades. So it will be dependent, na?
If Y is the case, if Y is just the queen of spades.
Yeah.
So if it is queen of spades, Y takes value 1. If it is not, Y takes value 0.
Or the example
So
would
then
be
both
like
both would be dependent, na? Then in
It
this
should
case.
be dependent. Even in that case also both
yeah,
are
that
dependent.
case also
Even this
dependent.
or it would be like
even in
X
this
is
simple case
taking
also it is dependent.
It is dependent, sir, because our experiment is only one time we are drawing the 4 cards. Na? We are just
Okay,
drawing
you
one
are
time.
see, yeah, if I wanted to talk about experiments, once if I am okay.
Sir, is this a dependent event? For example, X is I'm drawing 4 cards. So X is the event of getting queens, and Y is the event of getting face cards. It could be either king, queen, ace, or jack. So in that case, X and Y are dependent, right?
Even in
Yes.
that case also it is dependent. No, he's asking about 2 different experiments.
So if it is with replacement, then it would be dependent or not?
This and this, X and Y.
Yeah.
No.
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 With replacement, you cannot draw 4 cards that way.
Huh.
If it is without replacement, then it would be dependent.
Yes.
Drawing 4 cards means you are removing 4 cards in total.
Yeah. It is actually drawing 4 cards at a time.
Yeah. Yeah.
Okay.
Correct.
Let me
And
think about this.
we are counting the outcomes out of that. Some I think.
Okay. So see, I roll a die. Okay. If the face shows an even number, I toss coin 5 times. Okay.
Yeah, this is fine, sir. There are two experiments.
Okay, toss a coin 5 times. If it
Yeah.
shows odd number,
Yes.
toss a coin 10 times.
This is dependent, purely.
Okay, this is experiment Y, and this is okay. It's not Y. I shouldn't say Y. So this is
Yeah, this-
experiment 2.
Right.
This is experiment 1. Yeah, this is experiment 1 where I am throwing the die. Depending upon the number it showed on that experiment, on that particular experiment, I will perform the second experiment.
Right. This is good.
Okay. Yeah. Okay. So there will be dependent experiments. And
yeah.
So in IPL
How
power
to,
play,
then how to tabulate? Yeah.
How to tabulate this? See, these are just the experiments.
Okay.
Okay. So I say random variable X is number showing on the die.
Dice 1, 2, 3, 4, 5, 6.
And Y is probability that head is shown. Hello.
Yes, sir.
Yes, sir.
Yeah, Y is number of heads.
Number of heads.
Okay. So now range of X is, range of X will be 1, 2, 3, 4, 5, 6. Right? Number can be from 1 to 6. And what will be the Y? 0, 1, 2, 3, 4, 5, and so on to 10.
Yeah.
Am I correct?
Right.
Now see, now you just have to observe. See, this experiment, this particular rolling a die is independent of tossing a coin. Right? These experiments may be dependent, but rolling this die and tossing this particular coin is
Independent.
both are independent.
yes, sir.
Now, what does this mean? X is taking value 1 and Y is taking value 0. What exactly does this mean? At the same time, X is taking 1 means?
We
Dice
got
shows
number
number
1 on
one.
the dice.
1 on the dice, and Y is taking 0 means?
No heads, only
heads.
tail.
No heads. Number of heads are 0.
Now see, so number of X is taking 1 is it's an odd number. Showing, right?
So
if odd number is shown,
I have one doubt. Like suppose in case here we know that if odd number comes, then we are tossing 5 times only, right?
10 times.
5 times.
So what will be, what we will fill for the next 6, 7, 8, 9, 10? What will be that? Because that is for sure it's not going to happen, right?
See, 6, 7, 8, 9, 10 will only come this particular 6 and this particular box will fill, but this will be 0. So X is taking 2, that means X is showing even number 2 and getting 6 heads. So we are tossing only 5 times if we get an even number. So we won't be tossing 6 times. So if we toss 5 times and getting 6 times heads is not possible case.
Yes, yes.
Yes.
So in that case,
so here
for all the
here,
even X,
after 6,
it will be 0.
After 6 for all the even places,
we will fill 0.
0, yes.
Yeah. 0.
Okay. Okay.
Yes. Yes.
This will be 0. Okay.
Okay.
Yeah, and remaining will be filled accordingly. So getting 1 on this die has probability 1/6 into getting 0 heads when coin is tossed 10 times.
1/2.
All 10. All 10.
Right. So this will be the first entry in our particular joint PMF table. Likewise, we will fill the rest. So when X is 2, it is an even number. So getting X is equals to 2 on the dice has a probability of 1/6. and once it is an even number, we toss the coin only 5 times, and out of those 5 times, none of the times head appears, so it will be 1 by 2 power 5. Likewise, we will fill the table. Okay, we will fill this table.
Correct. Got it.
This will be the joint PMF of this particular random variable x and y. Okay.
So in IPL
So-
power play question,
Yeah.
the two things happen. We are taking x as number of wickets in 1 over and y as number of runs scored in 1 over. So, sir, in this case, it can be dependent. I think it
is
might be
dependent.
dependent in some case.
Might be independent. How?
So, might be dependent.
It is actually, I say it is actually dependent.
It is dependent. It is dependent.
It's dependent.
Yeah. See, basically, number of runs scored. See, okay, number of wickets fallen in that particular over definitely impact number of runs scored in that over.
Yeah. Yes, sir.
So that is what we discussed, right? It is not possible to get 6 wickets and scoring some 36 runs or 30 runs or even 5 runs. So if I say six wickets have fallen in that particular over, that means each and every ball is a maiden ball. That means runs scored on that particular over
Inversely
is very near to
proportional.
0.
But sir, if in any case there is 4 wickets fallen and 12 runs scored, so there is no dependency there. Maybe 12 runs scored, maybe 10 runs scored, something like that.
Yeah, there will be dependency, right? If the number of wickets are very high, so there is a high chance of scoring very less runs in that particular over, right? It actually
Yeah, but
depends.
let's
If
say
you are
sir,
scoring-
let's say sir, the wickets are falling in the end of the over. Let's say wickets are falling, let's say in the third, fourth, fifth, sixth ball. But the first and second ball can be hit for 6 or 4 kind of things.
Of course, there is a chance of some probability that first 2 balls can go to boundaries and next ball maybe dot and all the remaining are wickets. There will be some chance, but there will be a 0 chance of getting 6 wickets and also scoring some runs.
Yeah. Yes.
Sir, I've also
We
shown
can't-
a
we can't
scatter plot
certainly say
in
zero,
the
right?
presentation.
We can certainly say 0, right? Because of on a no ball, if run out, then
That
there
is
is
what,
a-
see, excluding that, let's assume, see, our first and foremost assumption is in that
all
over, in that
balls are
particular
genuine
over, only 6
probability.
balls
Okay.
are being bowled.
Yeah. Then that's good.
But sir, we can't say it is totally dependent because there are such cases which are like these two events may be independent.
See, the thing is, for dependency, it is enough to prove one particular event failing this particular property. Probability of x is equals to some t1 and x is equals to some t2. If it is not equal to probability of x is equals to t1 times probability of x is equals to t2, for one particular event, if this is failed, if it is not equal, so if this failed, then they will not be independent. So even for one case, if you can prove if this is failed, that means if my probability of x is equals to t1 and y, this is y. Probability of x is equals to t1 and probability of x is equal and y is equals to t2. If it is not equal to probability of x is equals to t1 into probability of y is equals to t2, then the both, see, that is what we have seen in stats 1 also, right?
Yes,
P
sir,
of
yes.
A intersection B should be equal to P of A into P of B. So if it is not equal, then they are not independent.
Yeah.
That means they are dependent. Even
So
here also,
in this joint PMF case, we can also say that x and y can be independent or dependent both.
no. So that is what I am saying. Even in one case, if you can prove this particular property is failing, then that will be a dependent. So even if there are some
No,
10
sir,
cross
but
10, if
what
there
her
are some
question
100
is,
entries,
sir, her question is there can be scenarios in which, I mean, even one is dependent, then entirely the sets are dependent, but there can be
Set is
scenarios where
dependent.
x and y are not dependent. They are not dependent. They are independent. There can be scenarios like these also, right?
Of course.
Yeah,
But
fine.
Yeah,
I
you
don't
can
think
That
that
pick
is
out
our question.
outliers.
But sir, in this course, we are doing the joint PMF kind of thing. We take X and Y always independent, na?
No. Who
Okay,
said?
they might be dependent also.
Of course, they will be.
We
There are
discussed here.
many
Here
examples.
we discussed here.
Yeah, see, this particular, even this particular case,
Yeah.
whenever in your joint PMF, if you are seeing 0 in one entry, then definitely 99.99 or 0.9999 probability, this will be a dependent. Both X and Y are dependent. Because you will see
Sir,
that,
yeah.
see here itself, I will take this example. Probability of X is equals to 2 and probability of and Y becoming 6 is 0, right? But what is the probability of X becoming 2?
The probability
1/6.
coming to is
Yeah.
1/6.
yeah, 1/6.
What is the probability of getting 6 heads?
0.
0.
Yeah, yes, sir, 0.
Only 5 times.
0.
No.
All
It
the
will be.
events, right? You should
When X,
But the cases, if it is
when
the
X
even
is
It
number,
will be.
2,
It
yeah,
will
it
be
will
marginal
dependent on X.
PMF.
Yeah,
For 6,
right.
we'll do
We
the
will
sum.
discuss that margin. Right. So see, when I say probability that Y is equals to 6, that means I am actually asking you what will be the probability that X is equals to 1 and Y is equals to 6? What is the probability that X is equals to 2 and Y is equals to 6? It is basically the marginal. I hope we will discuss that marginal also now. So you will get a clarity. Just hold on for 5 minutes. Once I discuss this marginal thing, we can discuss the independent and dependent cases also very clearly.
Shall we?
Sir, just
I mean,
one question. Someone, while you were discussing this card problem, someone said that you cannot draw 4 cards without replacement. I mean, with replacement. I didn't understand why this statement was made, sir. I mean, why
Okay.
we
See
cannot draw
that
4 cards with replacement?
we can
We
draw,
can, right? Yeah.
but
Okay.
our case is we are drawing 4 cards at a time. So that is what I explained also. So we are drawing 4
Okay.
cards at a time. So
Okay.
Shall
in
we
that
solve
particular at a
one?
time case, there will not be any replacements or such.
Yeah. Shall we solve one equation on the joint function, because I saw some of the questions that xy
Okay, then let's take, as we have discussed the week 1 of lecture 1 very slowly.
So
So we will
just
solve
one thing I would
example.
like to ask here. So if we are called to find the joint PMF, and if X, Y, and are independent, so we can find like probability of X equals to T1 and comma Y equals to T2 as probability of X equals to T1 into probability of X equals to T2. But if they are dependent, then what will be the case? How will find it?
If they are dependent, then you have to compute each and every value.
Okay.
In the table. Okay. Yeah. So let's take this example of question 4 and 5. So where it says that there is a function g of xy, x comma ys, x by xy by 9. Okay. So this and also we have ranges also. X is 1 comma 2 and y is also 1 comma 2. So this particular x can take only 1 comma 2. That
Sir,
means
sorry
very
to
simply
interrupt. One quick question. So when there is a dependent event, so the table would be like xy is different from yx, is it? Because x given y and y given, so we'll have 2 different tables.
not exactly. See,
because
here
which one will
the thing is, see this is just we are taking x to right of it and y taking in this.
Then it will become
If you
transpose.
take x here, it's like a transpose matrix. You will get the transpose matrix.
So we'll fill the value of x given y or y given x.
Both will be there in the table, right? Because if you see on the
Both will be there in the
example,
table.
yeah, 1, 0 and 0, 1, both will be there actually.
Okay. Okay, got it.
Okay.
Thank you.
So yeah, so whatever you are saying, it will become the transpose matrix. Okay, let us see this. So this is the PMF, joint PMF is given as G of x comma y as xy by 9. So where the ranges are also given to us. Tx ka range is 1 comma 2 and ty range is 1 comma 2. So what I will do is, firstly I will draw this table here. I will write xy and I will write all the numbers which are in my range of x, which are 1 comma 2,
1, 2 and 1, 2.
and all 1 comma 2. So now our table will be 2 cross 2. So we have to fill only 4 values here. Right? Now if you see here, g of xy, x comma y, where x can take 1 and 2. So what will be? So this is gxy, x comma y is basically probability that x is equals to small x comma y is equals to small y. Right? So this particular box, this particular entry is basically the probability of x is equal to 1 and y is equal to 1. So this, when I replace small x with 1 and small y with 1, I will get g of, okay, I will get probability of x is equals to 1 comma y is equals to 1, which is the value of this, which is actually equal to g of xy 1 comma 1. Right? This is the probability that x is equals to 1 comma y is, just substitute 1 in place of small x and small y.
Yeah.
1 by 9, 2 by
So
9,
this
2 by 9, 4 by 9.
so this gxy 1 comma 1 is just substitute 1 and 1 in x and y's, small
1 by
x and
9.
y's.
Yeah.
So 1 into 1 by 9. So this
Got
will
it.
be 1 by 9. So here it will be 1 by 9.
Next 2 by
Similarly,
9. Yeah.
what will be this? P
2 by 9,
of
2 by 9.
x
2
is
by
equals
9.
to 2 comma y is equals to 1. Right. So just substitute small x is equal to 2 and small y as 1. You will get 2 by 9. Similarly, this is also 2 by 9. What will be this?
4 by 9.
4 by 9.
This is, yeah, x becoming 2 and also y becoming 2. So this will be 4 by 9. Right? This is the this is how we develop the joint PMF table if a function is given. Now once we get this table, so there can be questions, right? Obviously, we don't leave you just to find the joint PMF.
The summation of all
In
the
order to make our
PMFs will be
life,
1.
huh?
Summations will be 1 total.
Yeah, initially after finding your PMF,
It is required. It is
for
required to check it.
Yeah, just cross check whether we have done it correctly or not.
Yeah,
So just first and foremost thing is check each and every entry is between 0 and 1 or not. It shouldn't be like this is you are getting 10 by 9 or something.
it will not be.
Right?
Total probability is 1.
Yeah, and also next thing is we have 4 values here. Just add all the 4 values. You should definitely get 1. If you are not
Yeah.
getting 1, then that means
Something
you are
wrong.
missing some values or you have computed it incorrectly. Okay. These are. Hello.
Yes, sir. Audible, sir.
Hello. Yeah.
Yes, sir.
Yeah.
You are audible, sir.
So these are 2 points. Each entry should be in between 0 and 1, and second one is sum of all entries equal to 1. So these are the 2 conditions you should check after you compute joint PMFs. And now my question is, what will be the probability that x plus y is equal to 1? Or what will be the probability that x plus y is equal to x minus 1? Or if I wanted to make a difficult one, probability that x is less than or equal to y. Okay, so we can ask like this. So we just wanted to ask some unions or some sums or some subtractions, whatever the algebra we use. So from this table, actually we can compute all of these values. So let us solve one by one. If you want, you can solve by your own very quickly. So this is our joint PMF we have. What I want is probability that x plus y is equal to 1. Okay. Just take some 30 seconds.
0.
0. Okay. So let's see. Any other answers other than 0?
What are you asking, sir? Addition.
Probability that x plus y, yeah. So I have random variable x, I have another random variable y. So now I have new random variable x plus y. So that new random variable taking value 1. What will be the probability that my new random variable z, so whatever this x plus y is a new random variable that is taking 1. Okay, tell me this, what will be the range of this particular random variable t of x plus y? So that means if I add two random variables, what will the range of that random variable, new random variable?
2, 3, 4.
2, 3, 4.
Yeah, 2, 3, 4. Right. Okay. Now my probability x plus y can take only values 2, 3, and 4. If I say what will be the probability of x plus y becoming 1? 1 is basically not in the range of x plus y. So whatever the values which are not in the range, that means the probability of that particular value will be 0, right? Right. What is the chance of getting 7 on a die? If a die is thrown, what is the chance of getting 7? 7 is shown.
0.
0. Probability is 0.
Right. So the same thing here also. So what I am asking is probability that x plus y becoming 1. X plus y can become 2. X plus y can become 3. X plus y can become 4, but not 1. Right. So that means this will be 0. Now tell me this. What will be the probability that x plus y is equal to x minus y?
0 is also 0.
0?
Yes, sir.
Right. Correct. Okay, let me. So tell me what exactly this means. X plus y becoming x minus y.
So y is equal to 0.
What? Right. So it is simply y is equal to 0. So just observe, when can, if my random variable x is taking some value a, random variable y is taking some value b. So what will be x plus y? It will be a plus b. What will be x minus y? It will be a minus b. When will this be equal? If a plus b is equal to a minus b, right? If these two gets cancelled, 2b is equal to 0, which implies b is equal to 0.
Yes, sir.
Right?
But that doesn't mean x is 0.
That doesn't mean x is 0. See, this is actually telling me that this whole sum is actually whole thing is actually telling me to compute the probability that y is becoming 0. That's it.
But still X can belong to 2, 3 and 4, right?
X can belong to 1 and 2. See, X is only 1 and 2, right? X can take either 1 or X can take either 2. Y can take either
Assume
1
the
or
value
Y
1
can
and
take either 2.
Then it probability is 0, no sir?
Probability even here also 0. But the thing is, okay, I do this. What if it is 0, 1 and 0, 1? Now what will be the probability that P of X plus Y is equals to X minus Y?
1 by 9.
1 by 9 plus 2 by 9.
By 9 plus 2 by 9, 1 by 9 and okay, just do it like this, na? Just take X plus Y as some other random variable, new random variable. X minus Y as the
It is
fourth
better.
new
Sir,
random variable.
it is better to make a different table. It is better, no, sir?
Better to
Make X plus Y table and X minus Y table.
see, that will take you long time.
Yeah.
Okay, even that is also a
And
process to do.
for this time to understand. Okay.
Yeah, for this time to understand, you can, yeah, that is what. Take this as a new random variable X plus Y. Look at the range of that X plus Y and calculate. So see, T of X plus Y becoming 2 probabilities. Okay, now it becomes 0, 1, 2.
0, 1, 2, right.
Now, what is the probability that X plus Y becoming 0?
1 by 9.
Right.
It's 1 by 9.
So X plus Y becoming 0 means X is 0 and Y is 0.
Y is 0, 1.
What is the probability that X plus Y is becoming 1?
That is 2 by 9 plus 2 by 9.
Yeah, 2 by 9 plus 2 by 9. Either X is 1, Y is 0, or Y is 1, X is 0.
Yeah,
So
2 by
this,
9, 2 by 9.
this and this, 2 by 9 plus 2. What is the probability that? So you don't need to compute this. If you have 5 by 9 here, it will be 4 by 9.
Yeah, 1 minus.
Likewise, just compute this one also. What is T of X minus Y? What will be the range of X minus Y?
0 and 1. 0 and 1, sir.
0.
0 and 1.
Right.
0 and 1, yes.
0.
0 and 1.
1.
Yeah.
Minus 1.
Minus 1.
Minus 1.
Yeah.
Minus 1 also.
Yeah. Yeah. Now tell me, what will be the probability that X minus Y becoming 0?
It will be 1
by
by 9
9.
plus 4 by 9.
1 by 9.
1 by 9 plus
1 by
even
9
1
plus
comma
4.
1. Yeah, 1 by 9 plus 4 by 9, which is 5 by 9.
Yeah.
And becoming 1 is 2 by 9.
Yes.
Becoming minus 1 is 2 by
2 by 9.
How is this, sir? How is this, sir? Please.
Getting 1 is actually X is taking 1 and Y is taking 0. This is the only possibility that X minus Y can become 1. Right? This thing, this particular thing.
X is 1 and Y
becoming
is 0.
minus 1, becoming minus 1 is X is 0 and Y is 1. So that is this thing.
X is 0, yeah.
Now, once we got the probabilities, now see, it's a matter of what we asked is probability that X plus Y is equal to X minus Y. That means when X plus Y is equal to 0 and also X minus Y is equal to 0, then X plus Y will be equal to X minus Y, right? Right?
And how it is 5 by 9,
Yes, sir.
How it is 5 by 9? 0?
This particular thing.
Okay, both we add it, right?
4 by 9.
minus
1 by 9
0.
plus 4 by
1
9.
minus 1.
Yeah, both will add it.
Right?
Right.
Okay, now see. x plus y becoming 0 means there is only one case 0 comma 0. X minus y becoming 0, there are two cases, either
Two
0 comma
cases.
0 or 1 comma 1, right? And you see x can take only one value at one time, and also y can take only one value at one time, right?
Yeah.
Right? Okay. So this is x and this is y. So when x takes 0 and y takes 0, okay, it is when x takes 0 and y takes 0, what will be my x plus y value? It will be 0. What will be my x minus y value? It will be 0. That means probability that x plus y is equal to x minus y when my x is equals to 0 and y is equals to 0. So in this case, my x plus y and x minus y are same, different.
Same, sir.
Same.
In this case, when x is equals to 0 and y is equals to 0, is my x plus y is equals to x minus y?
Yes, sir.
Yes. Yes.
Yes, right? Now, come here. So when my x is equals to 1 and y is equals to 0, what will be x plus y?
1.
1. What will be x minus y?
1.
Right. In this case also my x plus y is equals to x minus y, right?
Yes.
Right. So in this case, now
Sorry, sir, what did you say? 0, x is 0 and y is 1, right?
x is 1 and y is 0. This
Okay,
one.
fine.
This
X is 0 and
particular
y
one,
is.
x is 1 and y is 0. So if x is 1 and y is 0, x plus y is 1. X minus y will also be 1.
Yes, yeah.
Right. So this case also falls into this, and even this case also falls into this. But when you see this, x is becoming 0 and y becoming 1, what will be x plus y?
-1.
X plus y will be 1, but x minus
and
y will
minus
be
1.
-1.
Yeah.
Minus 1. So that won't fall in this case, in our
Correct.
case.
Yeah.
So this won't come. And 1 comma 1, what will be x plus y?
2.
Yeah, it will be 2, and that is
What
0.
will be x minus
0.
y?
0.
So even this won't come in our case. So the probability that x plus y is equals to x minus y will be 1 by 9 plus 2 by 9. This and this. Right? Which is same as if you know the marginal distributions, this is actually probability that y is equals to 0. So where this y is equals to 0 came is just solve this thing. When can x plus y becomes x minus y? If and only if y becomes 0. So this particular adding and subtracting is 0, then only we can have x plus y is equals to x minus y. So simply probability that y is, if you compute probability that y is equals to 0, it is same as 1 by 9 plus 2 by 9. Okay. So these are some questions. Once you compute this joint PMF, we can ask infinitely many questions on that. Okay. So this is how you compute joint PMF. And once you get joint PMF, we can play around probabilities of happening that event, this event, combining of those two events.
In our course, only two variables will be there, sir. In our course, or more than that also.
More than that also is possible. So even when you come to look into this IIDs, and you will come to see in week 2, week 3. Okay. So yeah, that is about the joint. And next thing is marginal.
So can I ask one doubt of joint PMF from activity question?
Sure. What is it?
Okay. So activity 1.4, question number 6.
Activity 1.4, that is not joint. Achha, those are examples of joint PMF.
But
Okay.
question number 6 is a joint PMF.
Okay, I will take it. Okay, so our X is uniform 1, 2, and Y be the number of aces obtained from a deck of well shuffled 52 cards in X, drawn with replacement. right?
Yes, sir.
Is that the question?
Yeah,
Yeah.
yeah, that's the question.
So what we have to do is, okay, we have to find the joint PMF,
Joint
right?
PMF.
So firstly, computing joint PMFs, first define what will be the range of the random variable x and what will be the range of random variable y. So x is given that it is uniform 1, 2. So the range will be either 1, either it takes 1 or either it takes 2, right?
Yes, sir. Yes,
So
sir.
tx will be 1, 2. Similarly, what will be ty? So it is actually number of ASS
Yeah, so it can be
with
0, 1
replacement.
or 2.
And let y be the number of ASS obtained from a deck of. In x draws, yeah, 0, 1 or 2 in x draws, right?
Yes, sir.
So in one draw you may get S or you may not get an S. So that
Yes,
chance is 0, 1.
0, 1.
And in two draws, when x is taking 2, you can get 2 S's or you can get 1 S or you can get 0 S's.
Yes, sir.
Right? So this will be now see my Tx. Now my table should be like x, y, x range is 1, 2, 0, 1, 2. Okay. As we have said, it is x is uniform 0, 1. Sorry, uniform 1, 2. What will be the probability that x is equals to 1?
1 by 2.
1 by 2.
Same goes to 2.
Yeah.
Yes.
Now, how do we compute this thing? So,
Sir, what does
what
this notation mean? X is uniform 1, 2. Just it means that it's distributed that way.
Uniform distribution. X is an uniform distribution with 1 and 2. Either it takes 1 or either it takes 2 with same probabilities, uniform probabilities. Okay. So now see y becoming 0. What does this mean? So here you see,
No S's.
don't say okay. So as y is dependent on x, it is given that depending upon x, y takes values, right?
Yeah,
So
yes, sir.
what does this mean actually? X is equals to 1 and y is equals to 0.
So
What
in
does
one
this
draw, there is
combinedly mean?
there is no S.
In one draw, there will not be a s, right?
Yeah.
Chance of getting probability x is equals to 1 is 1 by 2, right? X
Yes,
taking value 1 is 1 by 2 times, once it takes x value 1, what will be the probability that it is not an S? So out of 52 cards, I am
48 by
drawing one
52.
card.
48 by
By
52.
52.
Right. So 48 by 52. 1 second. Okay. Right. Now
Yes, sir.
this is the probability that x is equal to 1 and y is equal to 0. Similarly, now let's come to solve this. X is equals to 2.
So can you repeat this last one, 1, 2, because I'm in connection one outside. It's 1, 2.
2
Hello, I'm audible, sir. Network is having some problem. Perhaps everybody is facing. Whether other people are audible?
Yes, yes, you are audible.
Sir,
Yes.
sir.
No, sir is not audible now.
Yeah, he's facing some network
He's not
issue.
audible.
Just hang on. Some problem with his system.
Some
Just hang on.
problem is there, right?
Yeah, he will join back.
Hello.
In the meantime, somebody can
Yes, sir.
explain
Hello.
this one,
Hello.
but
Yeah. Sorry.
my network also. Please.
Hello.
Yes.
Yes, sir, you audible.
Yes, sir. You're audible.
Hello. Yeah. So now this particular thing we will compute. This is basically x is equals to 2 and y is equals to 0.
Sir,
Means
sir, could you explain this? What was the experiment? They card because network was not there.
okay. It's a
Card
small
drawing
experiment. So
please.
no, yeah. It's
Please,
an
sir.
x. X is a random variable which is uniformly distributed between 1 and 2. That means either it can take 1 and 2 with same probabilities. So probability of getting 1 is half, probability of getting 2 is half. So depending upon the x, we will draw the number of cards. Like if x takes 1, we will draw 1 card from 52 cards. And if x is 2, we will draw 2 cards from the deck.
Okay, fine.
With
This is the
replacement.
experiment.
With replacement. Okay. Once we draw, again we will keep it inside and we will draw another.
Okay. With replacement.
Okay, it's with replacement. Yeah. So now x is equals to 2 and y is equals to 0 means we are getting probability that we are getting x is equals to 2. That means we are drawing 2 cards with replacement, but we are getting 0 aces. So what is the probability of getting that? So getting x is equals to 2, it is half into. Now what is the probability that
48 by 52.
Yeah, it's again 48 by 52.
48 by 52 into 48 by 52, right? So in the first case,
how is it, sir? Please.
So in the first draw, there are 48 cards which are not aces divided by total number of cards is the probability of not getting ace in the first draw, multiplied with probability that we are not getting ace in the second draw too. So we will be drawing 2 times, right? If my x is 2, we will be drawing 2 times with replacement. Okay, this will be the probability that we are not getting ace in both the draws. Okay.
So I understood this question. So the one thing which I was facing problem is understanding what is the use of this line x is uniform 1 comma 2. I know there is something which can be used in this question, but what is the thing we are going to use here using this line px equals to 1 by 2? I am not getting this thing. Now I understood this question.
So this one, this is simply we just wanted to give it in a distribution way.
Yes, and now
So can you explain what's the y here? Like it is the number of aces drawn.
Obtained from a deck drawn x draws in x draws. Okay, x is basically that top x, this random variable x.
Okay, so in one draw, how
Y
many
is
aces you get? In two draws, how many aces you get? That's the thing, right?
Yeah, so if x takes 1, that means we are drawing only 1 time. If x takes 2, we are drawing 2 times. So depending upon this x, this one. So it's nothing to do with this x uniform thing. It's like we have given that probability of this thing here half, we are multiplying this half, right?
Yes,
probability of getting x is equals to 1, there it plays a role.
So I was able to do this 48 by 52 kind of thing, but I was unable to understand what's the meaning of this x uniform 1 comma 2. We have to multiply by half also. I didn't understand, but now I got this.
So see the thing, this is x is equals to 1 and y is equals to 0. So initially, what is the chance of getting x is equals to 1? So there this uniform plays role. Yeah.
Okay, sir. Thank you, sir.
Sir, could you please explain in this table when x is equal to 2 and y equal to 1? So do we have to take both the probability, like one first card is having ace?
Of course. X is equals to 2, y is equals to 1 is we are drawing 2 times and we are getting ace in one of the times, right?
Yeah.
So
So
that means getting x is equals to 2 has a probability of chance half into either 4 by 52 into 48 by 52. That means getting a's on the first draw and not getting a's on the second draw, plus 48 by 52 getting no a's in the first draw and getting an a's in the second draw. Right? This will be the
So one thing I want to
probability
ask,
that.
sir, are we going to discuss marginal and conditional probabilities in the same live session?
Of course, if time permits. I'm too late, I think.
So there are questions also that I have from the course.
Of course. Okay, then we will take questions rapidly. So we will
After you
discuss
have
rest of the
explained, right?
topics in.
Yeah. After that, that's fine. Sure.
That's fine, huh?
Yeah.
But as this is a new year, right? Don't you guys have any?
Yes, sir.
Even I am internally worried that if I go beyond 8 p.m., many of you are like, "Arey, ye kab chodega?" Or you have a liberty to leave. I know that, but the thing is, there will be
No,
few
sir,
people like.
we are here, sir.
No, sir, it's up to you. If we can't take it right now, I've just asked. I'm not saying you have to cover it here also. But if you can't take it here, so we'll take it into the next live session.
Sir, at the same time, if you are taking it,
Sir, I have a doubt.
we can sit.
No.
Oh, we'll sit here.
Okay, thanks. That's a nice comment. Maybe I can take it as a compliment. Okay, so we will quickly go look into marginal. So once I just wanted to set a right base before we get
Yes,
into
this is
difficult topics.
Yeah, it is better to go to the base point.
Yeah.
Sir, can you
So we
cover
have seen.
Poisson distributions? Poisson.
We will take it. Poisson is very simple. Okay, I shouldn't say simple. Poisson is a quite extension of binomial. Treat it like that. It will become simple. So once if you are talking about binomial distributions, it is like some n times or n draws, or considering experiment, we are making experiment only n times. But what if that n goes to infinite? What if
So it is
my
just a
number of
Bernoulli trial done infinite times, sir? Is that the idea?
Yeah, Bernoulli doing n times is a binomial, and where binomial n goes to infinite and chance of happening each and every event becoming zero, very near to zero, there Poisson comes into play. Okay, so simple case is that in a day, case is that a person visits a store in one particular time. Okay, out of 24 hours or 9 hours, so he can reach at 8 a.m. or 8:30 a.m. or 9:30 a.m. or there will be number of number of events become very infinite, right? Like
So
not
within a
infinite,
particular range, it
very
can
large.
take floating values and can take floating values between particular range. In that sense, you mean it's infinite, or like infinite in the sense it's going from 0 to infinity?
See, if I consider 8 a.m. as 0th event, so 8-1 will be my first event, another event. 8-2 reaching the person at 8-2 will be another event.
So 1
Reaching
minute
person
blocks.
8-3. 1 minute blocks, or I can take 1 second blocks.
Yeah.
See, that is what in an hours, wherever I just wanted to
That is
simply
similar
tell
to
what
continuous
Poisson
random
is.
variable, right? That is similar to continuous.
Very similar to continuous, but it's not continuous actually. If you see, it won't be continuous. Poisson is a discrete, but
Some discrete points in between a continuous interval, something like that.
I guess we lost self voice.
Is giving so much problem. The screen is visible?
Not now.
Okay. Some network issues there, perhaps.
Yeah,
Because
seems so.
some message also gave the temporary blocking of the service of my current course.
No, that was something different. They were updating at my.
Maybe some network issue is there in the campus is there, perhaps.
Yep. Yeah, probably he is taking class from his home only.
Yeah, maybe some problem. Network is.
Yep.
Today is getting so much issue.
Let's wait for a few minutes.
Yeah.
Hey, hello. Someone kicked me out.
Sir?
Oh.
We don't have that permission.
Yeah, but I was suddenly logged out from everything and Zoom unexpectedly closed. I thought kick
How
Sarah.
is that possible, sir?
We cannot do that, sir.
Okay.
Yes,
Only
Earlier
host can do that.
1004. I was like someone who want to go for New Year, and if you kick out me, they can.
No, we cannot do that. But we
Host,
thought that
can
we went
you?
for New Year celebration.
Huh?
Yeah,
Uh,
I
host, can you
want
make
to
me
take a
host?
break,
We are
sir.
running out of time.
it may be some party effect.
Host.
Probably host is in hurry.
Yeah, hurry
Yeah.
party.
Host.
Online party should be there. Omicron is coming. So nobody should go out. I think so. Very, very bad situation.
Sir, will we continue or you can continue? Like,
I will continue. I have to get the access of co-host. Without co-host, I cannot share my screen. Okay, maybe see the marginal distributions are quite easier. Once we get the joint distribution table, just add each and every row and column. So you will get the marginal distributions of x and y separately. So marginal distributions are basically the independent probability, not independent, the probabilities of getting that particular random variable. If you wanted to look at only one random variable, and if you wanted to ignore the other random variable for some time, what we will do is we will just add up all the values in that particular row or all the values in that particular column. See, if my column is of x values and
I think,
row
sir,
is
you're
of
not
y
sharing
values.
anything.
sir, in the sense
we will
of
get-
if we talk in terms of matrix, we can say we'll keep I fixed and we will add all j and k values. Something
Yeah,
like that.
right. If we talk in matrix terminologies, keep I fixed, keep the column fixed, and add all the values in that column. in that particular column. And similarly, all the values in the row, if you add all the values in that particular row, so if my row is of random variable y and column is of random variable x, so whatever I add in that particular columns will give me the marginal distribution of this random variable x. So
it is synonymous to row relative frequency like that.
I don't know about this.
Okay.
See, I am just know only mathematics and statistics, not data science. Hello? Yeah. So I will once again, I don't know. Okay, meanwhile, have you guys gone through all the week 1 contents and how does it feel?
Sir, I'm going to finish week 1. Still, I haven't started practicing.
Going through still something is left, sir.
Sir, I went through the contents and I can solve the questions also, but like even though I can solve the questions, like I'm feeling it difficult to interpret sometime, like interpret the result in sense.
Yes, sir. I needed more time to solve. I can solve the question, but I needed time to solve.
That is why once you complete this video lecture, there are some tutorials.
Some sound is coming, sir. Who is there?
Afriyal Iqbal, even I can't mute him. Because
We are also not able to see participants. Something wrong with the Zoom.
Iqbal. Can you mute, please, Iqbal?
Iqbal, please mute Iqbal.
Iqbal, can you mute, please? I don't even still not got the access of. It's like sometimes.
Maybe he's not there.
Maybe he kept it.
He is not there.
Left the phone or.
Sir, anybody is able to see participants, or it is out?
I can see participants.
Okay, you can see, but I'm not able to see.
Yeah, we can see participants, but we cannot mute them.
Even I cannot mute. So Iqbal, see, the thing is, it's quite a lot of disturbance. If you are
Yes, sir.
I think he left his mic on and he is not present.
Actually, he is engaged somewhere.
Sir, better you get co-host right immediately and.
Just a second.
उस समय हम साथ थे आ रहे थे, हमको याद है जो पैक करके लाए थे हम लोग भैया सब साथ में आए थे दिल्ली भाई था ना इसमें उसमें अंतर देखो
भाई इकबाल भाई बंद कर लो
ना भाई we can have
नहीं रहे
quite a good conversation.
Totally busy.
पैसा नहीं मिलेगा भैया कौन दिया दूध ठंडा में मैचिंग करेंगे खाली हजारीबाग से बरी आने बोल रही बेगो भर जाता है हम लोग हैदराबाद से तुम आए हैं कितनी परेशानी से आए हम यार जानती बदी वो आया और क्या बोलते हैं दोस्त आया
Okay, so even he's not picking up the call. Let's do one thing. Let's have anyway. This is not so productive. I feel this session. I should have discussed lot more concepts today.
Yeah, sir, he muted.
Yeah, muted. Please let us discuss on audio only, sir. In the meantime.
Yeah. So okay, if he has given me co-host thing, we can discuss marginal and conditional. Okay, let me ask these things. Okay, just go through these tutorials and solve. Try to solve those tutorial questions. Even you will get the answers right away.
I have one doubt, sir. In activity 1.4, question number 4, it's about Poisson distribution, sir. So there's one doubt.
1.4, question number 4.
Yes, sir. So we have to find the distribution of Poisson. In the video, sir told the distribution is lambda by 2.
Right.
So here it's actually the answer is the option number 4. So how does it work?
Okay. So I will give you a small idea. So whatever the SAR did, don't take the final output. Whatever he computed, his computation is about is like half and half. So chance of happening that event and not happening that event are same. Okay, he's taking equal chances. So that is why he got exactly half poison. But once you just follow whatever the SAR has done.
Yes, sir. Okay, sir. Yes,
Okay.
sir.
Follow with the probabilities. I will tell. So he has taken this thing, right? So binomial, poison with
Poison of-
lambda, poison lambda, right? So then he took and toss a fair coin n times, and that n he is taking binomial, and from there he got poison as lambda by 2. But if you see there, binomial n comma half, okay, chance of success is same as chance of failure in the lecture. If you observe in the lecture, okay.
Oh, yes, sir. Yes, sir. Understood, sir. Yes, sir.
But here, if you see, chance of success is different from chance of failure, which is 0.4.
Sir, is it like 10 minus 2? That's why it's 8. So
No. It is 0.4 and 0.6. Okay, so it's a ratio. It's like 2 by 3. So chance of success is 0.4, chance of failure is 0.6. So the ratio chance of success to chance of failure is 2 by 3, right?
Yes, sir.
0.4 by 0.6. Chance of success by chance of failure. Similarly, here also it goes the same way. Here poison 20, chance of success should be 2 times and chance of failure should be 3 times. How can you divide 20 into 2:3? Huh? How can you divide 20 such that the numbers obtained is 2:3? Or don't think this hard. Just compute whatever sir has computed in the lecture. Just go through the each and every step. Just substitute 0.4 in the place of success and 0.6 in the place of failure. Okay, eventually you will end up getting poison 8.
Okay, sir. I'll try, sir.
Am I? Just try. What am I thinking is I just wanted to have a duplicate session of this because of some, even I didn't feel that satisfied.
That will be better, sir.
Sir, in the
Now-
office hour sessions, I think you can address like the marginal and conditional.
In the office hours, I don't think. See, the thing is, schedules are already prepared, and I don't know whether I am the one.
Sir,
taking-
tomorrow we have office hours, sir. 8 o'clock.
Yes, sir.
Tomorrow office hours, yeah. MA 10. Am I? Hello.
Yeah, we can hear you, sir.
Okay. So, okay, I will take a look into this because this session was a lot of disturbances and everything.
Or with solvitors, you can discuss like.
Yeah, maybe.
together.
Definitely, we will. I will. Most probably, I will take an duplicate session. Maybe I say where I will discuss this marginal, conditional, everything other than 1.1 and 1.2, 1.1. So I will discuss till 1.6 maybe. See, the thing is, week 1 I don't feel like, if you have covered 1, 2, 3 lectures, it's like generalizing those lectures. 5, 6, 7 are generalizing them. That's it.
Yes, sir.
Okay.
So there are some unclear questions you are not able to
Actually, the
understand.
concept of joint, marginal, and conditional is okay. The way the questions are formed in terms of calculating probability is causing the problem.
Exactly.
Oh, okay.
That
once
is
you
causing the
come-
problem.
Okay, maybe I will come up with
Exactly.
quite a good example in the next session I have.
So, and the examples which Andrew sir has taken, or perhaps which we hear from you, they are simple enough to understand,
Yeah.
but when we move to the questions, it's like bouncer
Exactly.
or a yorker comes directly.
Yes.
So we
Yep.
don't know the tag to solve those
Assignment
problems. And
questions.
sir, one question, if I may ask, I know you will take the session later, duplicate. Just from one assignment question, I want to understand what is the question all about. If
Of
you
course. Those things I
can
can do
ask.
it right now. See, why I am stopping this session is I don't have access to share my screen, and
Sure, sir.
I don't feel like teaching when I didn't write it on.
Got it.
Yeah.
Got
Yep.
it.
Yep.
So it will
Yes,
take
sir.
Yeah,
time.
yes.
So
Better you
maybe
plan
graded, so
duplicate.
graded assignment. The first
Excuse me,
question,
sir.
what is it trying to ask?
Second.
Sir, it shows you are co-host right now. Maybe you can continue there. I mean, it's just showing on my screen. I don't know
Yes, sir.
what's going
You are
on.
reflecting as a co-host now.
Yeah. Exactly.
Okay. Let me then.
So we will continue today, or like we'll create a duplicate session some other.
Okay, I will just take 10 more minutes. Okay. I will.
Now it is okay, sir. Your screen is now.
Yes, we can see, sir.
Yeah.
We can
Okay,
see.
graded assignment one is it?
Yes, sir. Graded assignment 1.
Question number?
Question number 1.
Okay, so
sir, maybe you can read the question, then I can ask my doubt.
joint distribution of two random variables x and y. Is this the question?
No, 3 fair coins are tossed. Graded assignment, sir.
Okay. Even I just opened.
3 fair coins are tossed.
Okay. If the first head occurs on the first toss.
Now, sir, 3 fair coins are tossed. And again, if you remember, my question was in respect to this. 3 fair coins are tossed simultaneously. If the first head occurs on first toss, now we are tossing 3 coins together. What does it mean? First head occurs on first toss. How will you consider what is first toss? If 3 coins are getting tossed together, what is the first toss? What is the
Toss
first
is
head?
basically the first coin. So if you have 3 coins named 1, 2, 3. Okay. So first toss is like coin 1. So
okay.
Coin
So
1 showing
then that
you.
is the first head.
Yeah, first head.
Okay. So then if the first head occurs on toss 2, then you toss the second coin.
No, it's like if the first head is like 1, 2, 3, you place it in a row. So first head means now if it is on toss 2, that means it tells me that toss 1.
But sir,
whatever the coin 1.
when we toss, right, we can get 3 heads also.
Yeah, 3 heads also.
Then I mean, how will the points be considered? Because it says if the first head occurs on the first toss, you score 1 point. If the first head occurs on toss 2, but when we are doing the toss 2.
No, it's not toss 2. It's like consider it like this. Okay, you have kept 3 coins in a row. So numbering from 1, 2, and 3.
Okay.
So your first coin is your first toss. So with coin 1, you toss once. With coin 2, you toss once. With coin 3, you toss once. Okay. So the game is in the first coin itself. If you got head, you will only get 1 point.
Okay, then we would not do 2 and 3.
Not doing. Once we will do all the 3, but if head appears on your first toss itself, that means okay. If I say this is the answer.
So we're kind of observing, right, sir?
It's like 3 coins here. I tossed all the 3 coins. This is 1, 2, 3. If your first coin itself is an head,
then you get 1 point.
You will get 1 point.
Okay.
If you got tail here, if you got head here, you will get 2 points.
And if we get 3 heads, then?
If you get 3 heads, that means you are getting head on the first coin.
1 plus 2 plus 3.
Only the first head is counted then.
They are counting the first things.
So sir, sample space, what will be the sample space?
Sample space is all the 3.
No, will it be H HT into HT.
Yeah, this is sample space. But the thing is, you will score some points when something happens. Okay. If you got head in the first coin itself. Okay. Here itself, if it is head, they don't worry about second or third one. Once they see head on your first coin, they will give you 1 point. And if they seen head on the second coin but not on the first, then they will give you 2 points. If they haven't seen if they have seen tail and tail in the first 2 coins, and if they have seen head on the third coin,
then 3 points. Yeah,
then you will get 3 points. And if no head appears, you will lose 1 point.
-1.
Okay. Okay, it's not about number of heads here. It's about the first head here. Okay, that is what it tells. Okay, that is how the scoring will be.
Okay.
So in order to win, you should throw all the 3 coins, where your first and second coin should show tail, and the third coin should show you head. So that is where you can get maximum score.
Maximum points.
Okay.
Okay, sir.
Yeah. So from there will be some x random variable x and random variable y. Okay. The idea is like, see, the thing is, statistics or this probability type of questions, more and more of in our life also, we will see everything depends on the chance of occurrence of something in future. Right? What is the chance that I do study for 4 hours tomorrow? What will be the chance? Depending upon today, yesterday, and day before yesterday, how much you have studied. So that might reflect, that might be the factors. So maybe tomorrow is January 1st and you will study only 1 hour or something, or you won't study. Like this. So everything, whatever you do in your life, you have some hope, and in order to fulfill that hope, you will struggle to do something. And considering those struggles, you will get the chance of success, right? Whether if I do this, if I am able to succeed or not. So depending upon that, you will do the things. So everything relates to probability, right? So whenever we give questions also, it will be very easier for us to come up with real life examples. So everywhere there is a chance, and each and every chance is nothing but the probability. So that in that way we can complicate the question in numerous ways, where even sometimes we forget when we create. So we will create a question and even we forget how to solve it sometimes. So in order to achieve this, in order to cross this border, you have to solve lots and lots of problems. That's it. So whatever that is why you have 10, 11 questions in each of the tutorials, and you have 2 tutorials which comprises of 20 to 30 different types of problems, and also activity questions, and also practice assignments, graded assignments. Go through this each and every question. I don't say skip. There is no skip in this stats 2. Never skip a question. So if you didn't get, come here, ask us.
One thing, sir, in activity question also, sometimes a problem comes. Every time, I think live session is not available.
So there is a discourse, right?
No, discourse is also there. Discourse we are sharing, but every time it is not coming. So detailed answer to the activity questions, if any statistics available, then that will be helpful.
Okay, correct.
Because that is required, sir, because at the time of revision, because this is total intuitive questions.
Okay. What I suggest is, I agree to your point. Hello.
At least after some time, not right now. After some time, it should be available for the revision purpose.
Okay.
Because last time also it was not available, sir. It was very difficult to fetch the answers.
So can I ask another question, if you don't mind?
Please.
So practice assignment 1, question number 4.
Practice assignment 1. Question number 4. Okay. What is it? Let X uniform 1, 2,
Yeah.
3, 4, 5, 6 and Y be the number of times 2 occurs in X throws of a fair die. Is that, am I correct?
Correct, right, sir.
Correct.
This is the question, right?
So also the question is choose the incorrect options.
Yes.
Right? Okay.
Yes.
Okay.
So I was getting the second option also as one of the incorrect, but it said that it is right. I don't
Okay,
know.
we will do. Okay,
Thank
so
you.
remaining guys, we will definitely have another duplicate session of this, and we will discuss this marginal, conditional, and quick revise of week 1. Okay. So
Sir, you will be coming tomorrow for office hours? Like how? When will this?
that depends. I don't know. See, the thing is, schedule has been prepared, and we will decide whether one available, depending upon the availability of the instructors, we will assign. Okay. Most probably no, because today I am taking the session and tomorrow there might be someone. So yeah, that is why I'm saying apart from this, I will try to arrange something around on Monday before the office hour sessions or such. So maybe to quickly, not like this. As now we have set the base, we will just go quickly look into marginal PMF and conditional PMF and on 2 random variables, and we will generalize it. So on n random variables, we will try to look it in within a 1 hour. Okay. We will do it there. So whoever has the questions regarding this activity and practice, stay with me and we will do it in a half an hour. And rest of the guys, you can leave and have a great day and have a happy new year. Okay. Okay.
Happy New Year.
all.
Okay. Okay, practice assignment question number 4 we are discussing now. X is something uniform between 1 to 6 and Y is number of times 2 occurs. On X throws. Okay, so the options are probability of Y is equals to, so option B is incorrect. You are saying that option B is incorrect, right?
Yes, I was getting, I wasn't getting that as an answer. Yeah.
Okay. So as this is a conditional distribution, you can directly see. So this depends on this. So here itself, when X is equals to 4, it is given that getting X is equals to 4. What is the probability of X is equals to 4?
1/6.
Right. So it is, I can write it like this, right? Y is equals to 2, X is equals to 4 divided by probability that X is equals to 4. Right?
Yes.
So what does this mean? Getting two occurring 2 times on X throws. Right?
2 occurring
when X is equal to 4. Yeah.
Two occurring twice.
Yes, 2 occurring twice in 4 throws. Correct, right?
4 throws. Correct, right? So what should be this?
2 occurring twice.
2 occurring twice and not occurring twice among the 4 throws.
One by 6 into 1/6 into.
Okay, so there are 4 throws. Okay. So chance of getting 2 out of this 4 throws, chance of getting 2 in 2 ways is 4C2.
4C2.
Okay. Into chance of getting 2 ka probability is 1/6. Okay. This is 2, and not 2. Okay, not 2, not 2. Okay, now we have four different, not four different, four things to be kept in four boxes. So how many ways there are? 4 factorial by 2 factorial. These 2 and 2 are identical, and not 2 and not 2 are identical, and just compute number of ways in which I can put 2, 2, not 2, not 2 in 4 boxes.
Yeah, it's true.
Okay, it is 4 factorial by 2 factorial into 2 factorial, which is 4C2. Now getting 2 on this die, on this throw, has a probability of 1 by 6. Getting 2 will have probability again 1 by 6. Not 2 getting 5 by 6, not 2 getting 5 by 6. Right?
Yep.
Yes, sir.
Okay. Divided by and there is x is equals to 4. Chance of getting x as 4. What is
Is
the
1 by
chance of getting
6.
it? Is 1 by 6 divided by 1 by 6. So this will cancel. 4C2 is 6. So this and this will get cancelled. I will get 5 square divided by 6 cube. So what does option says?
Yeah, that says 5 square
5
by
square
6
by
cube.
6 cube. Right.
Okay.
So then it will be a correct option, and it
Yeah.
it
So
is
यही problem हो रही है. The calculation of probability is becoming bit difficult to
Yes.
find out in now, in this
Yeah.
course at least.
Yep.
Yeah, but with practice maybe
Yeah,
that will slightly
Yeah.
become easier. I won't say it will be easier. It may ease your calculation stuff. Maybe you will speed up your calculations once you
As a
practice.
concept, joint PMF conditional marginal is not difficult. It's the
Yeah.
probability which actually comes
Correct.
into picture now.
Correct.
Right.
Putting
Okay.
probability in the box itself is a difficult thing. Otherwise,
Exactly.
understanding is
Wherever you have standard questions where the joint PMF is given is being can be
Yeah, yeah.
done, but
Yeah.
numerical questions,
Okay.
it's
Correct.
okay.
Putting
Fine.
into
Got it.
the putting in the distribution is difficult. Otherwise, best are okay.
Okay. Maybe what I will do is in that particular session which I'm going to take, I will come up with a very good example where we will compute all the marginals. So we will start by looking into joint, marginal, and conditional, and we will take some 10, maybe 10, not 10, maybe 5, 6 different values, different types of probabilities, computing probabilities from the table. How we compute different types, I will come up with a very good example.
That will be great, sir.
Okay.
That will be great, sir.
Yeah. So I
Example
will
of
definitely,
different types. Yeah.
Yeah, I will definitely come up with.
Because we are not knowing, you must be knowing what type of examples should be integrated for that.
Right. Okay. I will come up with something like, yeah. So see, this is different from probability of x less than or equal to 2. Is different from the asking probability of x plus y is taking some value to.
Yeah.
And it is different from asking mod of x minus z is less than or equal to 2 minus y. Maybe 2 random variables minus
Some
y.
type of this.
Yeah, some type of.
Yeah, it is required, sir. So that we can keep as a notes also. So can we revise it frequent times.
Yes. Definitely. I will.
Right, no, sir. Because we are not
have
able
a
to.
short and crisp video.
That is.
Of some 1 hour, so that you can revisit that session again and again.
Revisit.
Correct.
Frequent times we will revisit it, then it will be better.
Yeah. So.
Because when it is a video of 2.5 hours or 3 hours, no, sir, then it kills the time. We do not go through
definitely.
So some videos are required, the crisp videos, so that we can revise it and then we will discuss it.
Okay. Maybe. When are your open hours? Tomorrow and?
Every day, perhaps.
No. With regards to statistics.
This time, statistics every day.
Sir, open hours or office hours?
Office hours.
Sir, office hours. One is tomorrow. One is tomorrow, and then next is on Monday, I think. Sorry, Monday.
Monday. Okay. Maybe I can.
Tomorrow and Monday.
I will ask Monday's
8 to 9.
session.
8 to 9.
Okay. Maybe I will take that Monday's open hour session and I will convert it into this quick summary of this 1 hour session. That 1 hour I will use it
Yeah,
efficiently.
quick summary is required, sir.
But sir, even for tomorrow,
sir,
in
quick
the
summary.
in the sheet there isn't anything.
They will update.
They will update. Okay.
They are in celebration mode. Maybe they will update.
Okay.
They will update. I will inform them. Okay.
Okay. Sir.
And so, who all are our TAs for the statistics too, apart from you?
Apart from me, there is Nikita Kumari.
Four are.
Mayur Gundal.
Yeah. Okay. So you and Mayur sir are familiar for us. You were there for Maths 1 as well.
Yeah. So yeah, maybe Nikita Kumari. She is completely working for stats too.
Okay.
She will. She is pretty good.
It's good that we have our previous TAs.
Even I am very happy to see you all.
Yeah, sir.
So I mentioned it in the last session. I hope so. It feels good.
We are tuned
when we
to
travel
you,
along with when we travel along with our students, it feels good.
Yep.
Exactly, sir. Right. Same from our side.
Yeah, maybe we have some type of maybe say some
Bonding
type of
kind of
rapport or some type of understanding.
Yeah.
Kind of thing.
Yep.
Okay. Then we will end this session today, and we will definitely have that Monday's open hour session. I will try to convert it into the revision session, and I will come up with a beautiful exam also. Okay.
Thank you.
Thank you so much, sir.
Okay.
Thank you, sir.
Thanks
Thank you.
a lot.
Have a good.
Thank you.
Yeah.
Happy New Year, everybody.
Happy New Year, sir. Happy New Year all. Bye.
Yeah,
Let us meet in the next year.
Sure. We will meet in the next year. Thanks all. Bye.
Bye.
Host, you can end the session.
Okay. Good night.
Okay. Host. Host. Okay, then chalo guys, then bye. I am leaving. You guys also leave and enjoy the night and tomorrow.